Hi everyone, how are you doing? Awesome! So last year I came and gave a keynote, and then I spoke to Adam, and Adam talked to me a bunch, and now I'm at Chef. So that's really awesome. I'm thrilled to be a part of Chef, and I'm thrilled to be back here again to talk to you about lean configuration management. So I should warn you, I'm not actually going to talk about lean configuration management. Well, I kind of am, but I'm going to go on kind of quite a long, 45 minutes discussion on stuff which is going to touch on both lean and configuration management. But this is a nice generic title to allow me to talk about what I want to talk about, which I decided about half an hour ago. So I'm going to start by kind of who works in a company of more than 1,000 people? That's quite a lot of you. More than 10,000 people? More than 100,000 people? Well, more than 1 million people? Okay. No one working for Indian Railways or the People's Liberation Army then? Okay. So all those of you working in big companies will have had the experience of this. So this is a diagram that I created that describes what an enterprise looks like. And on the left, you have the kind of golf-playing cadre. And in the middle, you have engineering. And on the right, you have IT operations. And Martin Fowler assures me this is valid UML for a big ball of mud, which is what everyone's running in production. And this is actually not too bad as enterprises go. There's no outsourced testing department. There's no outsourced development department. There's no distribution. At least you're all kind of in one place. But it's a static diagram. So what happens when we press play on this diagram? We have the machine that goes bing to tell you that everything's working. What happens when we press play is someone comes off from a very fine round of golf with an idea for a fabulous new product and says, well, let's build this fabulous new product. And after much wailing and gnashing of teeth and budgeting and detailed estimation and so forth, the project starts up in engineering. And after many months or even years of development, that thing gets tossed over the wall to IT operations, who then has to wire it up and make it work. Bing, it's working. And then that team disappears and goes and does something completely different instead. And that thing they built lives forever in production. And that's it. So there's a problem with this. There's many problems with this. But one of the main problems with this is it's too slow and it takes too long to get anything done. And the answer to this was supposed to be agile. And so, everyone goes and gets the 2-day Scrum training. And now we're all taking orders from management, standing up instead of sitting down. And that huge backlog of work that we can't ever complete is now prioritized and estimated. And now we're agile. Yay! But the agile transformation is inflicted, first of all, on the engineering department. How do we think the rest of the organization is going to feel about the fabulous news of the DevOps transformation? Are they going to be thrilled and excited? Boo! Typically that's not the case. The business is not typically thrilled about this because the whole point of Agile, right, is better collaboration between engineering and the business. And that means the business people get to spend less time on the golf course and more time hanging out with the engineers. And that's kind of awkward, and the engineers aren't really that into it because the whole reason people become engineers is so you don't have to talk to other people. And so there's a whole bunch of awkwardness in that relationship that's a bit difficult. And IT operations is not necessarily thrilled about the transformation either. Because instead of some nasty piece of crap coming over the wall once a year, instead we have new changes coming over the wall all the time. And the operations people are like, please stop the madness. And engineering are like, what? What do you mean? We're doing TDD. We're using loosely coupled, highly encapsulated systems. And IT ops is like, well, that's great. Shame it doesn't actually work. And so IT operations has a logical and natural and rational response to this problem. And that response is to create a barrier called the change management process. And the job of the change management process is to make sure that nothing ever changes. And so what we typically end up with is a process that I actually didn't coin this term. It was coined by a guy called Dave West at Forrester, called water, scrum, fall. And so what's happening here is you've got the Scrum teams and engineering working in their nice little iterations and doing these nice little slices. But to get anything done, you still have to have this extraordinarily painful budgeting process and then detailed estimation and planning and design before some enormous document lands on some poor project manager's table. And that typically takes weeks or months. And then at the end, those Scrum teams aren't building systems that you can just actually deploy into production on your own. Oh no. First, they have to be integrated with a bunch of other systems, and you have to make sure that everything works in an integrated testing environment. Then it has to be handed off to some QA department in some other country who, has a miserable time, frankly, working their way through manual test scripts which don't reflect the way the application actually works and trying to give some useful feedback to the developers so they can ignore it because there isn't time to fix those bugs in time to release it. And then, it gets tossed all to IT operations, and that's miserable too. That's the kind of last mile piece. Who's been there? Yeah. So that's real. And typically what we see is most companies who adopt Agile, who are large companies, end up adopting Water Scrumfall, and changing this kind of bit in the middle doesn't typically have a huge impact on the overall outcomes in terms of lead time or quality or cost or value delivered. And so what we see, and this is a quote about enterprise agility from the Economist Intelligence Unit, is I think we probably all recognize this fact. The problem is decision making is too slow, and frankly, based on poor information, people have differing and conflicting goals. Priorities, if we even know what they are, which a lot of the time we don't, often tend to conflict, and then risk-averse culture, silo-based information. So in my previous job, I was working at ThoughtWorks. We did a survey with Forrester on a bunch of kind of key decision makers, and we asked them what their relationship was with IT. So business people, what do you think about IT? 42% said they treat IT as a service. 43% said they treated it as a partner who works with us, and some much smaller number said, well, actually engineering drives innovation. Shocking. And this is pretty representative, and it drives what Marty Kagan calls the IT mindset. The idea that IT is a service provider that does what it's told, and when they deliver it, and it's not what the business wanted, which it never is, they're like, well, we do what you told us. What? Shut up. And this drives a lot of the poor, dysfunctional behavior that we see throughout the enterprise. There's a great study by some people at Sloan Management that was published in the Sloan Management Review on how you get from bad performance to high performance. So on the bottom left, obviously, it's a quadrant diagram. There's the maintenance zone, which is kind of the baseline. And then on the top right, there's 7% of the people they surveyed had really amazing IT, where the spending was lower than the baseline, and they had much higher compounded annual growth rate in terms of sales. But there's two ways to get from the bottom left to the top right. You can either go by increasing alignment between IT and the business first, which means up to the top left before you go to the top right, or you can focus on improving performance and then pursuing alignment, which means going along to the bottom right before going up to the top right. And it turns out which way you go is really important, because if you pursue alignment before you pursue performance, you end up in this alignment trap thing where you're spending 13% more than the baseline, but minus 1.4% in terms of growth rate. So you massively increase costs while reducing the organizational outcomes. If you go the other way, via performance, the results are much better. You end up with much lower costs and higher performance on your way to the thing on the top right. So what this tells us is, before you do anything else, if you're in Water Scrumfall, you have to pursue performance, high IT performance. And Nicole was up before the break talking about IT performance and what it means and how to do it, which is great because it means I can just rush through this part of the talk, which is fabulous. The first thing that she did in the State of DevOps survey last year was come up with what turned out to be a statistically valid model for measuring IT performance, which is quite a big deal. These four metrics divided the population up into three groups: high performers, medium performers, low performers. And we've got two groups of metrics here. At the top, lead time for changes, release frequency. Those are our throughput metrics. Performance, how fast can we go? And on the bottom are our stability metrics: time to restore service, change fail rate, to what extent do we screw things up when we go fast, or when we go slowly, frankly. And the big news really is that the high performers do better at both. It's not a zero-sum game, which is what DevOps has been saying since 2009. Obviously, we wanted to find out what correlates with high IT performance. So these were the top 5 things. app configuration, system configuration code in version control. And what was fascinating about this is it's more important to keep your app configuration and system configuration in version control than it is to keep your code in version control, which is somewhat counterintuitive, but demonstrates why Chef has become quite popular. Because actually, that whole thing about being able to reproduce your production environment from information stored in version control is the highest correlated thing with high IT performance. It's super, super important if you want to move fast. Secondly, getting failure alerts from logging and monitoring rather than from, say, Twitter. And then two things that warm my heart. I love surveys. They're such a rich source of confirmation bias. Developers merge their code into Trunk Daily, which is the continuous integration piece that Adam was talking about in his keynote. And then developers break up large features into small incremental changes. And this is, despite the name, I guess we should have called it iterative changes. Working in small pieces which deliver some part of the value but not everything, rather than working in really long feature branches that you merge right at the end. So, Adam was talking about why it's important to do that, but what the data very, very clearly shows is that that's what enables you to have high IT performance. So 10 years ago, I was talking about continuous integration and how great it was, and people would say, well, I'm sure it works on small teams, but in our big enterprise, it can't possibly work. And then about a month ago at Configuration Management Camp, someone came up to me at the end and was like, well, this continuous integration thing works great in Silicon Valley, but I don't think it's going to work on my small team. And I'm like, oh, really? On the one hand, I was super happy because, now I've got the other problem. On the other hand, I'm like, oh, well, this is never going to end. So, hey, I've got a job for life. Woo! And then the DevOps piece, when development and operations teams interact, the outcome is generally win-win, which is how you know you're doing it right, because people actually find ways. There's always going to be conflict. That's inevitable. But do you find ways to solve it in a way that actually makes everyone happy, rather than I'm going to use my organizational power to destroy you and thereby win? That, it turns out, is not a sustainable way to achieve organizational change. So using some statistical magic that I don't really understand, we then wanted to look at what predicts high IT performance. So you can go and ask Nicole about this, and she'll say a bunch of words that you'll be like, that sounds amazing, and I don't understand anything you just said. And she talks about peer-reviewed change approval process, which we know doesn't work. It massively peer-reviewed change approval process does work. Having external change approval processes like the CAB doesn't work in a very particular sense. I don't want to say it's useless, because there's a way to do it right. And in fact, the guy who's in charge of ITIL tweeted me, replied to a tweet that Jessica DeVita made yesterday, quoting me saying, CABs don't work. And he tweeted back, they can work sometimes. And I'm like, oh, just pissed off the guy who runs ITIL. Whoops. And he's right. There is a way to make it work, but it's not the way that most people do it. So the problem is this. The reason why it doesn't do anything to improve stability while dramatically reducing throughput is, imagine that you're in the cab. Right, so first of all, who in this room is an engineer? Who's written code? Put your hand up if you've written code. OK. Keep your hand up if you've written code that you thought can't possibly break anything, and then it broke something. OK, everyone's still got their hands up. What about that? And so you were on that team, and you knew that code base super well. And you still made a mistake about the impact of that code change on the production system, because guess what? They are complex systems, and we cannot predict the impacts of our changes. So imagine now you're in the cab, and you are looking through hundreds or thousands of changes by a whole bunch of people on a code base that you don't understand, because you're probably not even a coder. Or even if you do understand it, what chance have you got of predicting the outcome of those changes on the production environment? Zero. It's insane. Sorry. Thanks, Bridget. It's insane. It can't possibly work, which is why it doesn't work. So it turns out that having someone look at your code by pair programming or do a lightweight code review process is a much more effective way of actually finding out, getting feedback on what you're doing. And it's much quicker as well, and you've got it fresh in your mind. You can actually have a discussion about it and make changes based on what that person tells you, rather than 3 months later, after you wrote the code, having someone say no to everything you wrote in the last 3 months, which is not very useful as a feedback mechanism, frankly. Version control, everything we've already talked about. Proactive monitoring, we've talked about. and then the other thing that Nicole talked about is high trust organizational culture, which we'll come to in a minute, and then the DevOps piece as well. As Nicole said, the top predictor of organizational performance was job satisfaction, which is these top 4 things. The other big predictor of organizational performance was actually using data from production to make business decisions. How about that? Who knew that would work? So I want to spend a little bit of time on culture, because this is what's going to tie it back to the configuration management piece. So my favorite definition of culture comes from a woman called Shanley Kane, who's the editor of Model View Culture. And this is what she says about culture. Our true culture is made primarily of the things no one will say. Culture is about power dynamics, unspoken priorities and beliefs, mythologies, conflicts, enforcement of social norms, creation of in-out groups, and distribution of wealth and control inside companies, which I think is actually very perceptive and comprehensive definition of culture. And captures the fact that it's pervasive and ubiquitous, but we can't directly sense it. Once you're in it, you know what conversations you can and can't have with which people, but it's not even necessarily conscious anymore. It just filters into your behavior and changes your behavior in ways that you, frankly, all of us find hard to analyze. So the way we measured culture, as Nicole said, was based on this model from a guy called Ron Westrom, who was a guy who was studying safety outcomes in healthcare and aviation. So these are industries where when things go wrong, people die. And she talked through the various pieces of this. There's just kind of one thing I want to focus on. The heading that he gave this model of culture in his paper on this, which you can go to on that link, it's in the British Medical Journal. How organizations process information. So what this model predicts is information flow within the organization. That, for me, is what configuration management is all about. It's about enabling information flow. It's about enabling people to see what's going on when something goes wrong, to actually have real data on what the state of the production system is and what changes were made to it, on what people have done who contribute to those changes, and what people are doing right now. That information is what allows you to recover from failures and also to know what the effects of your actions are in terms of the changes you make and the features you build. It's all about information flow. That's what creates safe cultures and high-trust cultures and innovation cultures as well, because what's fascinating about this is the same factor that predicts failure outcomes also predicts our ability to innovate. This model that was designed to predict safety outcomes predicts how well we do at IT performance and culture, our ability to innovate. And it's all based on information flow, and information flow is what configuration management is all about. The point of configuration management is not to store all the things, it's to communicate all the things, so everyone knows what's going on, and we can make rational, information-based decisions. These things allow us to move fast, and the measure that we particularly focused on is lead time. Why is lead time important? Well, there's 3 major reasons. We talked about, or Nicole talked about, moving from time between failures as a measure of stability to time to restore service. The ability to restore service, once you accept that failure is inevitable, that complex adaptive systems will always drift into failure, you've got to accept that changes are going to break things. And the question becomes, how soon can we restore service? And the key question I like to ask here is, who has a normal change process that's different from their emergency change process? Okay, lots of you. What don't you do in the emergency change process that you do in the normal change process? Testing. How good an idea is it when you have a serious problem in production to not test comprehensively the change you are about to make to it to try and restore service? But it's a brilliant idea. It's a terrible idea. So when people ask what should we aim for in terms of lead time, my answer is you should aim for your lead time you should aim to be able to use your normal process to make emergency changes. If you have to have a different process for emergency changes, your normal change process is broken and you need to fix it. That also means we can quickly get critical fixes to users. In the medical field, one of the earliest disasters on computer-based medical equipment was a radiation machine that was used for radiotherapy, there was a race condition where if you hit the buttons in a certain order at a certain time, it would deliver a 10x dose of radiation. And a number of people got serious radiation poisoning and died as a result of this problem. Now, the medical industry is heavily regulated, and it takes a long time to get changes out. But in this situation, you want to be able to test that change and get it out as fast as you possibly can, because people are literally dying or being poisoned as a result of that software bug. And any process which prevents you from actually getting a fix which will solve that problem out, even if it's something which disables a whole bunch of functionality so that those buttons just simply can't be pressed, you want to get that out as soon as possible and as safely as possible. And then finally, in the context of business applications, the third thing we want to do is validate rapidly if the features we're building are valuable. So most of you will have seen this slide from Amazon, I'm sure. Their deployment stats they presented at Velocity in 2011. I still show this today to people because it's just so good at making people's heads explode. And actually, they're a lot faster now. So this is 2011. They're faster than this now. And the same with the Etsy presentation, the Flickr presentation from 2009. People have two responses to this, which is either that's awesome or that's total nonsense, and these people are crazy. And it turns out there's a bit of both, because this is aggregated across all the thousands of services that make up Amazon. So some of those services, like services in a cardholder data environment that subjects to PCI DSS, are not that fast. But some of them, to other services, are very fast changing. And what this allows you to do is be much more fine-grained about the risk profile of those different services and make decisions based on that risk profile, rather than having a one-size-fits-all risk management and compliance process, which is death for anyone actually trying to move fast. One of the reasons they did this was to enable them to avoid building features that weren't valuable. So most new features in Amazon, as with most other web platforms that are doing high-velocity IT, they test new features using A/B testing. And so I was lucky enough to get Ronnie Kahavi to speak at QCon a couple of years ago in San Francisco. He's the guy who developed and designed Amazon's A/B testing platform and went on to lead the experimentation team at Microsoft. He has a ton of data from A/B tests, online experiments, Amazon and Microsoft, and this is the data that he shows. Evaluating well-designed and executed experiments that were designed to improve a key metric, only about 1/3 were successful. What this means is that 2/3 of the feature ideas they had turned out to deliver zero or negative value to customers. And we often think about the zero value case, but what about the negative value case, where the feature actually makes things worse? That's a disaster. And those features kill us in 3 ways. Firstly, there's the opportunity cost of not building a feature that would deliver value. Secondly, those features live forever, because no one deletes features. And third, they add complexity to our production environment, which slows down the rate at which we can add new features. This is the biggest source of waste in software development, the stuff that we build that's useless or worse than useless. We could be spending 3 days of our working week on the beach and deliver the same value to our customers if only we knew the 2/3 of the features we built that deliver zero or negative value to customers. It's a disaster, and that's one of the reasons why Amazon invested a ton of money and time and effort into achieving this, which was super complicated for them, and I'll talk about it a bit later, but it took them 4 years to do this because it's super hard. But this is one of the major reasons that they did it, to avoid building the features that don't work. And so getting here is the performance part. You remember earlier I showed you that chart? You've got to pursue performance before you pursue alignment. So getting there is the well-oiled IT performance part. And then you can pursue alignment. And alignment means building the things that are actually valuable and not building the things that aren't valuable. And ideally you do that not by getting a bunch of project plans from the business, which gives you a list of stuff to keep you busy for the next few months, but actually by a process of experimentation, like A/B testing, where you find out what's valuable. The problem with the kind of upfront process, where you get a big requirements document, is that this word requirements, actually. So whose requirements are they? Are they the requirements of our users? Users don't know what they want. Users know what they don't want once you've built it for them. They're the requirements of the customers, the people who pay you the money, the business. I have a word for requirements which I think better represents what they actually are. Guesses. And I think we have to be honest about this. And the problem comes from the process of actually defining the requirements. One of my favorite books from the last couple of years is a book by Gojko Adzik called Impact Mapping. And it's a very simple tool where he basically looks at the outcomes that you want to create, which are on the left-hand side of the graph. And as Adam says, these should be business outcomes or customer outcomes. And then you look at the stakeholders who have the ability to achieve those outcomes. And then the next level down is how those stakeholders can help or hinder achieving those outcomes. And then on the far right are the things that you could actually do to achieve the outcomes, which are what you get when you get a requirements document. So someone upstream who wrote the requirements has basically, whether or not they were consciously doing it, they have in their heads, created one of these, and then chosen a single path through it, and then handed you as a requirement the single path through that map for everything they gave you. Consider the amount of information loss in that process. What you got was the leaf, one leaf from this graph, which was your requirement. And someone made a guess as to which leaf in this graph would achieve this outcome. And maybe you don't even know what the outcome was. And maybe the person making this graph and then choosing the path through it didn't know in clear terms what the outcome was that was clearly defined in measurable terms. So the information loss in that process is appalling. And that's why most of the stuff we build doesn't deliver the expected value, because we've basically taken a whole bunch of information and ideas about who the stakeholders are, what they could do, and what things we could do to actually achieve those outcomes, and massively reduced all of the context and information on those decisions, and then handed them to a bunch of engineers as a bunch of orders on what they should do, and then not giving them any feedback mechanisms to find out if they'll actually achieve those outcomes, which is a disaster. So this, I think, is a really cool tool that you can use when you get engineers and IT ops people and support people and business people in a room to talk about this, and then talk about the experiments you can run to test which of these ideas is actually going to produce the expected outcome. And when we do this, and we have this information, we can then make decisions on what we're going to build and what money we're going to invest in what things based on economics rather than guessing. So in that survey I showed you earlier, we asked a bunch of business people how they made investment decisions in what to build. So 47% said committee decides from potential options. 24% used some kind of economic model to make their investment decisions. That's a good idea. Just for a joke, we asked people, one of the answers was the opinion of the person with the highest salary wins out. 13% of people said that's how they made investment decisions. So, kudos to the people at Forrester, because they got those people to be much more honest than they would have been if they had actually been talking to you in real life. So nice, but very depressing. 9% of people said they used a product portfolio approach, which is kind of like a crappy way of saying they think they're being systematic when they actually aren't. And then 7% said no systematic approach. So what that means is that 24% of people are using an economic model to make their investment decisions, and 76% of people aren't. That's pretty terrible. And it's not because they're stupid or it's not because they're evil, it's because they have no basis for making those decisions. There's no feedback loops to discover if the things they want to build are actually going to work or not. So I'm going to switch focus now and talk about how you achieve some of this. And so Adam covered a lot of this in the DevOps Kung Fu, so I'm just going to fill some of the gaps in there. Because I only saw Adam's definition of the DevOps movement, of DevOps this morning, my definition is going to be slightly different, but that's okay. We're currently at a stage in our movement where, things are different and things are shaking out, and we're still very divergent. And I think the time to converge is probably not yet, but the time for discussion is absolutely now. So I sent him this. He sent me his. We're yet to kind of agree on it, but I have this definition of the DevOps movement, which has a lot in common. As a cross-functional community of practice dedicated to the study of building, evolving, and operating rapidly changing, secure, resilient systems at scale. And that's where a lot of this stuff came from. I will say, That's not where I came from when I came across the DevOps movement. I was building large applications for enterprises of the kind that I described at the beginning. So my path into DevOps is very different from Adam's path. And what's really amazing and cool about that is that here we are a number of years later with actually some pretty similar definitions of what it means to be good at this stuff. And of course, everyone knows the key, one of the key practices at the heart of this, infrastructure as code. And honestly, kudos to James Casey and Seth Falcon yesterday, presenting what I think was the first time I've seen a totally unified tool chain and workflow that describes this, how to operate this whole thing. So that was amazing, I thought. But the key thing at the heart of this is being able to create feedback loops. How can we create feedback loops so that we know the things that we put into this system are going to achieve the expected outcomes? And step one, as Adam said, was continuous integration. And so the slides I like to show about continuous integration, people still ask me, someone came up to me yesterday and asked me, do you really believe that it's okay to check changes into trunk on a daily or more frequent basis? Basically, people react to this claim that we've been making in the Agile community for 15 years now, that you should check all changes into trunk on at least a daily basis. People treat that in two ways. They either think that it's nonsense and it can't possibly work, or they can't believe why anyone would not do that because it's really obvious. And it's still the most controversial thing I claim today. So I like to show this slide from Google, where they have more than, well, way more than this now, but tens of thousands of developers in tens of offices worldwide, with thousands of projects under development, everyone working off trunk. So everything gets developed and released from trunk, everything gets merged into trunk. 50% of their code base changes every month. And they're submitting, on average, 20 changes into trunk every minute. In order to do that, they had to evolve a very comprehensive test suite and run a lot of tests a lot of the time. And it does help that Google has more servers than God, which enables them to do this. But this was not something they just dived into. This took them 4 years to evolve this culture. And there's an article on Martin Fowler's blog, which is actually about the Heartbleed bug. But it's a very long article, and there's a part of that article which discusses how Google created a culture of test-driven development. And they had a team which was doing all kinds of crazy things. Like there was a program called Testing on the Toilet, where they would print out a newsletter on how to do some kind of testing and stick it to the back of the cube, so there was no way to ever escape being told that you should learn about testing. You literally couldn't escape. I'm going to take a break so I don't have to think about code anymore. Yeah. But this comes to the heart of what we're trying to do when we want to achieve velocity at scale. The only way to do that, you can't inspect quality in afterwards. You can't have a change advisory board that inspects stability in afterwards. You can't have a bunch of security people look at your code at the end and inspect security in afterwards, or availability. You can't take a system that developers haven't designed with security and scalability and availability in mind and sprinkle the magic DevOps dust on it and have it magically scale and be secure. That doesn't work. The only way to do it is to build quality in. We can't rely on mass inspection to build these things, which is why the water scrumful process doesn't work. And this is where the DevOps thing is so important. Everyone has to understand how to build these systems. And we don't know. No one knew how to build a site like Facebook or Amazon when they built it. What they did have is feedback loops, so they could find out which of their decisions achieved the desired effects and which didn't. And that's the key pattern at the heart of continuous delivery, the deployment pipeline, which is what Chef Delivery allows you to model. The idea that every time you make any kind of change to the system, we get rapid feedback that's not comprehensive, but tells us if we did anything really dumb within a few minutes of checking into version control. And that's this build and unit test step here. If that breaks, we fix the problem straight away. Quick pop quiz. Who's practicing continuous integration in this room or on their team? Put your hands up. Keep them up. Put your hands down unless all the engineers on your team are checking into trunk, merging into head at least once a day. If that's not true, put your hands down. If when you do that and the build breaks, it's not typically fixed within 10 minutes, put your hands down. Okay, so the people in the room with their hands up are doing continuous integration, and that's actually a very large number of you, so congratulations, that's really cool. But continuous delivery is not running Jenkins against your feature branches and then ignoring the build when it goes red. You actually have to fix the build, which I know Adam said, but I'm going to say it again because it's really hard. Once you've got a build that passes the basic tests, then it goes downstream for more comprehensive testing and so forth. And the point of this is you're trading off fast feedback against comprehensive feedback. And you're not wasting expensive people and resources for these kind of downstream tests like performance testing UAT against builds that aren't known to be, at least able to stand up in production and not have any like really bad regressions. However, this requires you to think differently about architecture. And what Amazon did also means you have to think differently about architecture. My favorite quote on internet architecture is actually from Jesse Robbins, which he made back in, I think, 2007 on O'Reilly Radar. He said, "Success on the web depends on continuous deployment of reliable software to an unreliable platform that scales horizontally." And that, in like one sentence, describes how to do web architecture. I really love it, and it's incredibly prescient. I don't think he said continuous deployment. I kind of paraphrased him, but he basically did, because no one had invented the term at that point. This is what people understand who build web-scale architectures. And the key thing is that these things that you actually have to get right, you can't sprinkle the magic pixie dust on at the end. Resilience, security, scalability, and then the continuous delivery piece, deployability, and testability are architectural concerns. You have to be able to deploy your application on your own workstation and be able to run tests and get a pretty good sense of whether or not it's going to run in production effectively. If you have to wait until your application is in an integrated testing environment that may take days or weeks to provision, and requires a great deal of work in order to stand up, in order to get a decent level of feedback of whether your thing is going to work, you are going to lose. If you have to deploy your entire production environment in one go because you can't independently deploy the pieces of it, you are going to lose. These things are architectural concerns that you have to care about from the beginning. And this is the main reason why people find it so hard to implement continuous delivery, is because they need those integrated testing environments to get feedback. They need to deploy everything all at once. They can't deploy those things independently. Those are architectural concerns. So one of the best stories about changing from the kind of big ball of mud architecture to a service-oriented architecture is from Amazon. Who's seen Steve Yeager's platform rant? Okay, a few of you. So this should be required reading for anyone who wants to understand how to affect large-scale architectural change. In 2001, Amazon had a big ball of mud in production. It was this system called Obidos that ran on some enormous Oracle database, and they ran out of horizontal scale for the database, which is why they were forced to re-architect. And something weird happens that doesn't normally happen when you're going to re-architect, which is that the CEO sent a memo to everyone in the company describing the constraints of that re-architecture. Now, we don't have the text of that memo, or maybe someone does, but they're certainly not showing me. But Steve Yeager summarized it in his platform rant thus. Do you want me to read it for you? Okay, all teams will henceforth expose their data and functionality through service interfaces. Step 1. Step 2, teams must communicate with each other through those interfaces. Step 3, there will be no other form of inter-process communication allowed, no direct linking, no direct reads of another team's data store, no shared memory model, no backdoors whatsoever. The only communication allowed is via service interface calls over the network. It doesn't matter. Step 4, what technology they use. HTTP, Corba, PubSub, Corba, God. Custom protocols, doesn't matter. Bezos doesn't care. He should care if it's Corba. That's terrible. 5, all service interfaces, without exception, must be designed from the ground up to be externalizable. That is to say, the team must plan and design to be able to expose the interface to developers in the outside world. No exceptions. And that step is super important. The customer wasn't the internal people. The customer was people in the external world, and I'll come back to this. And 6, anyone who doesn't do this will be fired. So this is the part of the memo I'm not so keen on. But Bezos was pretty serious about this. He hired a guy called Rick Dalzell, who is an ex-Army Ranger, a West Point graduate, to go around the teams and see if they were breaking these rules. And if you were, he would shout at you a lot. And if you kept breaking the rules, he would try and have you fired. So they took this pretty seriously. And it took them 4 years to do this, from 2001 to 2004. And during that time, they more or less didn't deliver a whole bunch of new features. And Bezos basically told the shareholders they could suck it up. No new features, sorry, we were architecting. Which is actually a crazy thing to do, but very important. And that is one of the things that enabled them to achieve those crazy numbers I showed you earlier. The other thing that they did, which was super interesting, was, and I'm going to put words into Werner Vogel's mouth, but it's OK because he said them. You build it, you run it. So basically, instead of this horrible kind of thing which we see so often in real life, you basically take these services and treat them as if they were products. And instead of using the project paradigm, which drives so much of the dysfunction that we see in real life, where you take, a project and build a huge batch of requirements, each of which represents a single path through a very complex map, and hand them over to someone else to go and build for several months and then find out if the idea was actually any good. And no one gets to say that it's not good, because by then you've spent millions of dollars on it, so we can't admit to that. We treat these services as if they were products and apply a product development paradigm instead of the project paradigm. So I don't actually recommend burning your engineers. That's, but I do recommend this idea. And this is not the only way to achieve this. You don't have to reorg to achieve these outcomes. But this is how Amazon did it. They reorged around the concept of teams, each of which had the power to individually deploy to production. They didn't need to get people from another team to tell them whether they could do things or whether they could deploy or anything like that. And they architected around that constraint that each team had the power to deploy. We still got the machine that says bing. And crucially, the operations team and the platform that they built was also a product. The way that AWS got built was that Ben Black and Chris Brown and Chris Pinkham, who were South Africans, wanted to move back to South Africa, and Bezos was like, OK, off you go and build EC2. And they asked Jesse Robbins for some servers in order to build EC2, and I've actually got an interview on camera where Jesse Robbins says that he tried to have them shut down because there was no way they were getting their hands on his servers. So they went off and built that primarily as an external-facing product, not as something that Amazon.com was going to run on. Amazon.com only ran on, moved to AWS in around 2000, I believe. So it was built as an external product that followed the same rules as every other product they built. And that is the other key piece of the lean configuration management thing, is this step 5 is super important, even for your infrastructure and your platform. And this is where, containers are fabulous. I love containers. I think they're awesome. But it can't be containers all the way down. The platform and the infrastructure that you build, you're still going to need to do a whole bunch of stuff to make that work and to integrate with all the existing stuff that you have in your production environment, which is why Chef and the original Chef configuration management thing is still an essential part of solving this problem and building the product that you're then going to have your developers be able to ship containers onto. But this product development metaphor is the key to this. And it's what enables all the other stuff to happen. I want to finish by telling a story from Amazon. So this is a blog post from Greg Linden, who was working on the shopping cart team. And this is back in 2007. He wrote this blog post, which means the actual thing happened a few years before this. So when you go to a grocery store and you go to the checkout aisle, there is candy and other stuff that you might want to buy, and you look at the candy, you're like, I'm not going to buy the candy because that's bad. And then who's got kids? All right, so your kids are like, I want candy, and you're like, oh, don't buy the candy. And so what Greg wanted to do is build a personalized one of these so that based on what you had in your cart, it would offer you personalized recommendations for what to buy based on what other people had bought that was the same thing that you had bought. And he made a prototype and went to the VP of product and said to the VP of product, what do you think? And the VP of product said, that's a terrible idea. It's going to distract people away from checking out. under no circumstances should you go and build this. And so Greg's a little bit sad. Goes back to his desk, takes his prototype, pushes it into production, runs an A/B test, gathers a bunch of data that shows that actually this prototype is going to create a considerable increase in revenue. Goes back to the VP, shows the VP the data. VP, it's fair to say, isn't thrilled, but nevertheless doesn't fire Greg and says, well, clearly we need to go and build this, and they built it, and there we are. Who works at a company where it's even conceivable that you could push something into production and gather data against the express wishes of a VP and not be fired? So that's pretty good. That's a lot more of you than would have been the case 5 years ago. But I think this is the important thing. Greg Linden ends his blog post with this quote. I think building this culture is the key to innovation. Creativity must flow from everywhere. Whether you're a summer intern or the CTO, any good idea must be able to seek an objective test, preferably a test that exposes the idea to real customers. Everyone must be able to experiment, learn, and iterate. So I want to finish this presentation by just making a little observation. Look around at the people in this room. What do you observe about the demographic? Yeah, there's lots of white dudes. And I like white dudes. I'm a white dude. But it doesn't represent the population at large. And one thing I want to say is, if anyone can change that, it's the people in this room. The reason I joined Chef, or one of the major reasons I joined Chef, was that this community is the most amazing community of any product I've ever seen. You are all amazing, and having you all here to talk about this stuff is amazing. You're fabulous and unique in this world. But what that means is we also have a responsibility. And I think the responsibility we have is not to let this slide. And it's a slide, so that was a pun that I made by mistake. Awkward. This is real. And this, in my opinion, is the reason why we have this problem. It's not because anyone's evil or stupid or bad. It's because we don't pay enough attention to this and we let it slide. So the one appeal I would make to you is, let's have it when we come back next year. Let's practice continuous improvement. Let's work every day to make this better. And to notice these things and to pay attention to them and to fix them when we see them. Thank you very much.